the fun part about this is I'm seated between the two people that run the dang thing. Liza has been the longtime showrunner for our debugger. You're now focusing on our data science work. What will you be talking about today?
Yeah, thank you, Paul. Today I'm going to show you several useful tricks which you can use during debugging in PyCharm. I'll be using a local project for that, but all of these features, except for project configuring, can be used for remote cases as well. And also I'm going to show several tips for working on data science tasks.
Everything comes back to data science, doesn't it? And you just, yeah. And Andrey, oddly, has a background in data science, and now you're going to be picking up the debugger work. So what are you going to be covering?
So today I'm going to show you how to use remote debugging. For example, how to debug your application that is run on a remote server or inside a Docker container. Then we'll discuss a less known technique, which is known as Python remote debug run configuration. And at the end of my section, I'll give you a brief overview of how our Python debugger works, since this is a question people ask quite often. I guess everybody wants to know how to do the magic.
You can't tell people the magic, then it's not magic anymore.
Yeah, it's not magic.
It's not.
Yeah.
All right, here we go.
Thank you, Paul. Okay, as I've already said, today I'm going to use a local project configured in PyCharm. Today we're going to show a Tetris game created with arcade module. It is a very useful Python library which allows you to create arcade games with Python really quickly. You can find the source code of this project in my GitHub. This link was posted to the chat. Also today we're going to use Python 3.8. It's the fresh release of Python. It was released in October 2019. And if, for example, you haven't tried Walrus operator yet, today you will have a chance to look at it right during our webinar. And some other news. Today I'm going to use JetBrains Mono. It's a new font which was released just a week ago. It was created by JetBrains specially for developers. So it was created for reading source code. And here, for example, you can see the page of this course of this font at our site. It's extremely beautiful. It's very interesting, and I strongly recommend you to look at it when you have time. So let's go to our program, to our Tetris game. Of course, in PyCharm, when we have already all the things configured, we can just right-click, execute run, and PyCharm starts our file. And here we can see figures, we can move them right, left, we can rotate them and do a lot of cool stuff and fill rows so they will disappear. That's really great. Games are really interesting. Yeah, so let's try to understand how our program works. Here is the instance of my game class, which is the main application class, and it overrides, for example, method onDraw, which calls some other methods, for example, drawGrid. It has some parameters like self.stone, self.stonex, self.stone.y. Let's try to understand what's going on inside this method. For example, we have parameter offsetX and offsetY. What can we do? Of course, the first thing which we can do is add printing, print statements. So, of course, we will use f-strings because they're very useful and very powerful. And when we execute this file, a lot of output will appear in our console. That's not really good. So we will be smarter. Today we are having advanced debugging course. So we'll replace our print with logging. There is a very good built-in module called logging in Python. Here we can just add debug. We asked PyCharm to import this module, and also we should configure logging right in the beginning of our file. So we should pass the file name where this log should be stored, for example, my.log, and also debugging level. Since we are debugging our program, let's configure it as debug. And now we again right-click and run our program. What happens? Wait for a minute, some figures appear, we are moving them, we are rotating them. Let's stop our program and check the contents of our mylog file. Yeah, that's true. It's full of numbers, different strange numbers. It's not easy to understand what's going on here, but we'll try to do so. Well, what can we do? But we changed this, our source code. That's not very great. Let's just revert. Okay, let's just revert changes of our, which we did, and try to do some more interesting things. For example, try to use debugger. There is a very good built-in debugger called PDB, which you can start right inside your program, calling something like this: import PDB, pdb.setTrace. It will start debug session with PDB, but since we're using Python 3.8, we can use a cool feature which was added in Python 3.7. We can call built-in function breakpoint. It calls default debugger, which was defined with debugger hook, either with environment variable or with calling method in standard module sys. So we added this call. By default, it's PDB, of course. So we call run one more time, and interactive PDB session is started here. We can check the location where we are. We can check the value of some variable, for example, offset y, and of course we can continue execution. But it's quite not very convenient to type all these commands and do some other stuff. But we are inside the integrated development environment. That means that we can use Visual Debugger. Let's try to do it. How we can do it? As everything is very easy inside PyCharm, again, you can right-click and call debug instead of run. What happens now? You can see PyCharm started a bit complicated program, and it starts pydivd.py file from helpers folder and passes path to the script tetris.py as parameter. We will see it later, but now, yeah, we can see that our program is executed. As with usual run, we can move figures, we can do all this stuff. And let's do something with debugger. For example, put a breakpoint here. Great. We put a breakpoint, and that's absolutely great. We can see the values of variables, which is located here in the center. For example, offset x, offset y. We can see the call stack, the place, the functions which were called before we appeared in this place of our program, and which is pane we will check later. Okay, so we have breakpoint, and of course we can press resume and resume execution of our program. And we can see resume appears many times. Well, we are a bit tired of it. Let's try to remove breakpoint. But I'm afraid to forget this location where I put this breakpoint. So I can right-click, and this menu appears. I can uncheck enabled. And what happens then? When I click resume, the program execution is continued. You can see the figures are started to move, and everything is absolutely great. But I won't forget the place where I put this breakpoint. Now I can go back to source code, check enabled, clicked enabled, and now the program is suspended again. The cool thing is that I can, for example, if I have many breakpoints in my files, in different files in my project, I can go to view breakpoints menu. I can call find action, which is very useful inside PyCharm. I can call view breakpoints, and it will open the list of all the breakpoints in my project. Here is this Tetris breakpoint on line 202, which is disabled, and here is another breakpoint, and I can manage them right from this menu. Okay, let's check some other options which are available here. For example, I can uncheck option suspend, and menu has become a bit bigger, and there is this very interesting option, evaluate and log. That means that I can put some expression here. Of course, it will be f-string again, and I can put some expression which should be evaluated on every time when breakpoint is hit. So what happens now? I check enabled, I unchecked suspend, and I enabled logging. And resume again. What happens now? Hey, where is my program? My program is here. Yeah, it works. But what happens in my console? You can see that my console is full of numbers. That means that this expression, which was in our breakpoint, it works exactly like logging. I can just go to this option again, suspend, and yes, so I quickly converted my breakpoint into a logging, and I didn't change any line of the source code. I just added breakpoint right during the debug session. There is no need to restart. There is no need to change everything. Everything is just very easy and very simple. And you might notice that there is one more option. It's condition. I can define it here as well. And breakpoint will suspend the program if and only if the condition is true. So let's define it when offset x value is 0 and resume program again. Okay, now we moved the figure left and breakpoint is suspended. That means that the offset x value equals true. That is, the current figure is on the left side of our board. Okay, that's great. Now we know how to work with breakpoints, how to quickly convert them to loggers, and how to define conditions for them. And let's try to do something with our code. As you've already seen, when you start our Tetris program, there is already this bottom line. We should wait a bit. This bottom line is already filled with color, but board for Tetris should be empty in the very beginning. I don't like this line, so I would like to remove it. Okay, let's go to our program. Here is our my game instance, and there is this field self board. Let's try to call find usages for it. All the usages are separated into two groups, value read and value write. Value read is not very interesting for us, but value write exactly what we need. Self board equals none is not interesting for us. Some strange functions are also not great, but there is this call self board create new board, and it looks like this is the exact place where our new board is created. We can check here, and yet our board is list of lists, like two-dimensional list, and the last row is filled with ones instead of zeros, so we should fix it right now, and let's try to run our program one more time. What happens now? Yeah, here is NaNoCat. It's really great plugin. You can I'll show you in the end bonus tip. Look, something has happened. We changed source code, and of course we received exception. What happened here? We can go to console, and we can see index error. List index is out of range. Okay, that's not really great, but why program suspended here? We didn't add any breakpoints here. It happened because by default, PyCharm has exception breakpoints enabled. You can see here in the list, we always have Python exception breakpoint enabled with activation policy on termination. That means that if this exception leads to program termination, your program will be suspended. You can change it and, for example, enable on raise, and after that, every exception which appears in your program, even if it's surrounded by try except block, it will lead your debugger to suspend the program. But by default, we catch only exceptions which lead to program termination. So that's why we are stopped here. Let's try to understand why it happened. We can evaluate expression. I've selected this value called evaluate expression, and you can see this expression is already there. We can evaluate it. It equals 21. Also, we can check the length of our board, and it equals also 21. Okay, now we understand why we've got this index error. We're trying to call too big index. Let's save these expressions for the future because we'll check them. We can insert them here and add them to watches. This expression and another one is length of board because it's also very important, and we can check that these values are equal. Okay, let's try to fix it. It looks like we need to insert some condition, so we will avoid this very big, okay, with very big index. Let's check if our index is too big or some other exception, blah, blah, blah. Then we should return true. That means that collision appeared in our program. But also you can see that we have this expression which is repeated here twice, and we are using Python 3.8. And now means that we can use some features of Python 3.8 like walrus operator. Let's try to introduce, well, variable, new y, and use it like this and replace this expression with new variable. Now it looks much more cool. And now we're using new features of our language, our favorite language. Then start our debug session one more time and try to check that our issue is fixed, that we fixed this terrible exception, which we introduced into program. Okay, we need to play a bit. Let's just check that everything is okay in it. Okay, not very smart move. But you can see we introduced another bug. The bottom row is already filled with figures, but it doesn't disappear. Okay, this is how software development works. You try to add some minor feature and you got exception, you introduced yet another bug, and well, let's try to fix it. Thanks God we have great visual debugger inside PyCharm, so we can do it right here. Let's go to my game instance and search for usages for my board one more time. We've not interested in value read. Here there is a method called remove row, and let's try to go there and check what's okay. It's called here. Let's try to understand what's going on here in this method called drop. Okay, we can of course put breakpoint somewhere, for example here, and start debug session for our end, for example here, and start our debug session. Wait for a moment. Well, again, something happened. Okay, our program is suspended, and we would like to understand what's going on inside this function or in these places. Of course, we can use different evaluate expressions or check values of my game instance. Let's just call step into, and here we can step over this function join matrices line by line. Okay, there is a long iteration here. I'm a bit bored of it. I can call step out, and I quickly go out of this function and do some other stuff. For example, I can call step into my code if I accidentally go into library code, or even execute run to cursor. If I'm here, I can just right click and execute run to cursor, but I also need to remove breakpoints and do other stuff. In fact, here we can see that when we are checking for matrices, we iterate over all the values in our board row by row, but we are skipping the last row. Here we have this index -1. That means that we are going to skip the index -1, and that means the last row. So the fix for our bug is going to be quite simple. We just remove this line, and now let's try to execute our code one more time. Okay, again, playing Tetris again. That's why I decided to use this code. I just wanted to play Tetris on my working hours. I think it's a great opportunity. Okay, I'm not lucky enough, but we need to fill the bottom row just to check. Yeah, we fixed our bug. That's great. And PyCharm Visual Debugger helped us with that greatly. Okay, so now what we can do. Now we know how to work with line breakpoints, how to quickly define conditions for them, and how to convert them into logging without changing source code and without restarting your program. Also, we know how to work with exception breakpoints, and they know that they're defined by default. And also, we know how to work with stepping actions inside PyCharm. And most likely, if you are working with Python, most likely you'll work with some data science tasks. And since I'm focused on data science tasks and data science features in PyCharm nowadays, I just want to show you some useful features of which are available in PyCharm for these cases. For example, here is just a Python file with just some computations. You can, of course, you can put breakpoint in any Python file, and it doesn't matter is it an arcade game or data science or just a website. You can just, again, right-click, call debug, and let's wait for a bit. Something happens here, and after that, our breakpoint is reached, and the UI is exactly the same. You can see variable values and call stack. But also, we have variables, several variables, which are NumPy arrays or pandas data frames. And you can see these magic buttons, view as array or view as data frame. You can just click them, and PyCharm shows you a beautiful table with the contents of this array. So you can check it. It works even with a very, very big arrays because PyCharm loads them asynchronously. So there is you shouldn't be afraid about inspecting really big variables. The same works for data frames, of course. You can, for example, format these values. And yeah, it works. It was an old bug, and thanks Andrey for fixing it. Yeah. And of course, you can evaluate expressions. Oh, sorry, not load. You can evaluate expressions and also check results of these expressions right inside PyCharm, right during your debug sessions. And most likely, if you have some data science tasks, you might be using Jupyter notebooks. And PyCharm Professional supports Jupyter notebooks as well. As this support appeared in PyCharm in 2019.1, and this is how it looks. On the left side, you can see the source code of your notebook. On the right side, you can see the preview. And you can execute cell here with run cell. PyCharm starts a local Jupyter server for you and shows you values of variables available inside your kernel. Of course, you can add breakpoints, like put breakpoints, and call debug cell. And after that, debug session is started, and it also looks like an usual Python file. Also, not only breakpoint supported, of course, you can step into function. You can see this function defined in this cell, and you can iterate over values here. You can step even inside functions defined in the other cell. So you can see here, I stepped into other function, into other cell, which was defined there. Yeah. And even if you're importing some, code from Python file, of course, you can import Python module inside your Jupyter notebook. Again, you can put breakpoint here, call debug, and you need to wait for a moment. And yeah, we're suspended here, and we can step into, and we stepped into Python file, which we called right inside from the cell from our Jupyter notebook. So this is really cool. If you do some computations or work a lot with Jupyter notebooks, you definitely should try it in PyCharm Professional because it's really cool. And of course, its debugger is also very useful. Okay, it looks like my part is almost done.
All right.
I think now I'm ready to answer questions if we have some of them.
We have a lot of questions, a lot of good questions. And you know what's nice about being the host? I
What?
can ask the first question.
Oh, that's great. I'm ready, Paul.
So, and this is an easy one, but it's me wanting to promote the thing that I always want to promote.
Yes.
So we have a nice, pretty visual debugger, right?
Yes,
We have a nice, pretty visual testing tool, right?
that's true.
Is it possible to do debugging during testing?
Yes, exactly. Thank you very much for your question, Paul. Unfortunately, I don't have
don't
an
show it,
example
but-
right now, but you can configure your tests. And of course, as an usual Python file, you can just put breakpoints there, start debug session, because PyCharm automatically creates run configuration for you, and you can debug your tests. That's absolutely great. You can also do stepping, check exception breakpoints, and all the features of usual debugger are available for tests.
I do TDD and I do this all the time. In fact, 3 years ago, when you did those CPython speedups, I just run and debug all the time now. I don't, switch over to debug. Okay, on to the questions. From Dimitri, your first question. It's a good one. If you can read this in PyCharm, I'll read it. In PyCharm, is there an alternative to running python-m pdb script.py, which will drop to the debugger upon an exception? There's actually in newer Python, there's something better than that, right? The keyword, but you can answer both.
We have, I think, one thing to stop your debugger at exception, we already have Python exception breakpoints, which I showed during my demo, and you can define them either by default, they stop your program if this exception leads to program termination, but also you can configure them so your program will be stopped at any exception, even if it doesn't lead to program stop.
Which leads to the next question about postmortem debugging.
It's available. This is how exception breakpoints with on termination policy works. This is exactly what I showed during my demo with Tetris game. So
what happens if you when it terminated, it wasn't running in debug mode? You can do postmortem anyway?
No, I think no.
It doesn't collect the information.
You need to try. But PyCharm debugger is almost as fast as usual run, so you can run it all the time, and you will automatically stop at exception right inside your program.
All right, we have a question about debugging in Docker, and I believe Andrey will be talking.
Andrey will be talking about remote debugging and all the possible configurations for that. So
And as a point, I believe everything you showed is available in Community Edition, right?
Except of Jupyter Notebooks.
Except the Jupyter Notebook part. Andrey is going to show some things that are available just in PyCharm Professional. Okay, so that takes care of that. Can you log to a file from the breakpoint evaluate feature?
In fact, breakpoints have a lot of options. The best thing, I think, even check it not here, but go to run, view breakpoints, and for Jupyter, no, that's better put Python line breakpoint. Well, it's not the best place for breakpoint, but you can do a lot of stuff here, and you can log it, log into the file. Okay, now I think it isn't possible.
Well, the questions are coming in fast. You really have a bunch of people that are interested. Okay, is there a way to view variables in the IDE while the program is stopped at a breakpoint? Did you show that? Like just the normal variables view?
They usually appear. All the variables available in the current context of your program.
Cool. This is one that I think you will enjoy answering about displaying functions and methods in the debugging window variables, like callables and all that kind of stuff.
We by default
stack-related features and things like that.
I think is it about variable view? Oh well, the question is quite big. Now structure. By default we show only fields which are not callables. So for example, here we can just start our debug session, and you can see that it doesn't show. It shows only fields which are not callables. But for example, here there's the instance of my game. It shows only like instance of classes or some primitive types, but not methods available of this class.
Right. And for you intermediate users out there, as you move around in the stack in the left column, all the values.
Yeah. But you can check the call stack on the left side.
Okay, we have too many questions, so we're going to have to move on, but we have to answer the most important question. How do you get the rainbow cat?
Oh yeah, sorry,
like
I totally forgot.
Asking.
Yeah, oh yeah, this is very important thing. You should go to PyCharm preferences or settings, and here this is just a usual Python plugin. So you can go to plugins, market plans, and type none-cat. Okay, it's installed for me. It's called non-progress bar. It was created in fact by JetBrains developer, and you can just install it like any other usual Python plugin. PyCharm plugin, and you will get this beautiful progress bar everywhere.
The rainbow cat.
yeah, it's very important.
All right, thank you very much, Liza, for this part. Please help us answer questions, and we are going to switch over to Andrey. And let me get the mic. Sorry for the noise. All right.
All right.
Here we go.
Is my screen visible?
It looks good.
Looks good. Hello again, everyone. So, okay, remote debugging. Remote debugging comes in two main forms in PyCharm, which are remote interpreters and Python remote debug run configuration. You will see the difference shortly. As you may guess, the main use case for remote debugging is web development. For example, when you develop your application on your laptop and then deploy it to a remote server. I'm going to use the Django tutorial polls application, which can be found here. It's, by the way, a great starting point if you don't know Django. I have also prepared a virtual machine where I will deploy the app with Django pre-installed, so just to save us some time. All right, now we're all set up. Let's discuss the remote interpreters and start with the SSH interpreter. I'm opening the project. Let's run the project locally just to make sure everything is working. All right, here we are. So let's try to open the application. So it's located on localhost and the entry point is here. Okay, so you can see the list of available polls. For example, are you enjoying the webinar? Here are the possible answers. I can say for you, but I'm really enjoying it. So let's vote for yes, I am. Vote. Okay, everything seems to work. Now I'm gonna add a remote Python interpreter that is located on the virtual machine and use it for running the application. All right, let's stop the local application. So we are going to add interpreter. We're going to add SSH interpreter. Okay, host. Host is the IP address of the virtual machine I'm going to deploy my application to. So let's figure it out because I don't remember which one is this. Okay, terminal. It seems to be it. Copy and copy and paste it here. Username. Very secret password. So I think interpreter is Python 3 since I'm using Python 3. And here is an important part. We need to choose the folder where our project will be stored on remote machine. Temp doesn't look a reasonable candidate for me, so let's pick something better. Here you can see that we can navigate through the remote machine file system. So I'm going to choose something like home projects and put it like advanced debugging part 2. Okay, here we go. Finish. Now let's run let's run our application using the remote interpreter in debug mode. So here we go. The application has started. Oh, something went wrong. So what's wrong? Let me check it out. Okay, let's figure it out. So let's see if my application is okay. It's on the remote machine. So let me check it out once again. So let's make sure that the application is uploaded. Okay, so here we are. So it is here. So let's try to run it once again without debugging. Okay. Now the trial directory. Okay, so let me figure this out. All right, so parallels, Python 3. So no such file or directory, but it should be there, isn't it? Projects. Manage by, it's here.
Oh, Andrey, it looks like you have a typo. You have advanced debugging part 2. No?
Oh, yeah, so thank you. So I need to put it, okay. Thank you, Liza.
And thanks to our listeners.
Yes.
They suggested
Yeah,
the fix.
so mapping, so advanced debugging. So here it is, yeah?
Yeah.
Seems like here it is. Oh, so could you point me out to the mistake?
The file path contains E. But it
Advanced.
should be advanced. Can you hear? Can you see the file path?
Where is it?
Here it is.
Oh, okay, kind of. Oh, yeah.
Pair programming.
Yeah,
We are programming right now, yeah.
Live
So-
programming.
So advanced debugger. So, all right, I see it.
Where did you type your?
So let's just, okay, I know what to do. Let's remove this remote interpreter, just to be sure, and do it once again. Add interpreter, SSH interpreter. Oh, not this one. So I just need to copy and paste the IP address here. Oh, wow, that's not it. Here we go. Sorry guys for this. Let's just let's remove this from the remote machine to be sure. Python 3 here. And let's check the path again. Projects, okay. So and advanced. Yeah, debugging.
I'm checking
Part
spelling.
2. Liza, thank you. Thank you for checking. Okay, finish. And let's try to debug it once again. And so what is happening? So the mapping should be fine. Ah, okay, I know what's we are not synced now. So here we are all synced. And no.
Try to restart it one more time.
Restart the debugger.
Yeah.
Oh, yeah. That's now we are synced. Now we are synced, and now the debugger should work as expected. Yes, yes. Here we are. Here we are. So, sorry guys. So for my bad typing. Now we sorted it out, and this is how the developing is actually happening all the time. So now we can see that our application is run on the virtual machine. And here is the IP address. We can get access to it. So let's do it. By the way, we forgot the important part. Let's put a breakpoint here in the vote function. And let's try to vote using the remote application. Pause. So what's wrong again? Oh, okay, I forgot the port number. So are you still enjoying the webinar? Sure. I'm enjoying the webinar. Oh, and we have hit the breakpoint. From here, you can see you can inspect the request that you just got. You can do stepping and all the standard debugging stuff. All right. Now, the good news are the PyCharm allows you to debug Django templates, not actually only Django templates, only Jinja 2 templates, but I'm using Django templates here. So let's put a breakpoint to the results template. Here we are. Let's put the breakpoint on this line and resume our application execution. And now we have hit the template breakpoint. As usual, you can inspect the variables that are available in this context. You can do stepping, where in the cycle, so this is expected. Okay, so let's remove this breakpoint and resume. And let's check. All right, so everything is working as expected. So far, so good. Not actually that good, but we sorted that out. Now let's try using Docker. Let's stop the virtual machine application and let's try using Docker. Add interpreter. Choosing Docker. Now PyCharm will allow us to select one of the Docker images available locally. So I'm going to use Webinar Django app. This is a standard Python Django image where I've added Django just in order to save us some time again. Okay, created. And now we're using Docker image to run our application. Let's try to debug it again. Now you can see that our application is run inside the Docker. We can use the local host to get access to the application because Docker maps its ports to the local machine. Let's try to vote again. I think, of course, it's the only option we haven't tried yet. And we have hit the breakpoint again. And again, you can inspect the variables, you can stepping through the code, and so on. Great. So we can resume. Let's check that the application is working. Great. Okay. Now there is an interesting use case. Imagine that you are developing a microservice that will be deployed to some microservices cloud infrastructure. As a consequence, you are out of control of how this microservice will be run, but you still want to debug it. So in other words, you cannot just click this funny bug button and debug your application. The solution is to inject some debugger code into the app and ask it to connect to the IDE as soon as it reaches some place in a program. This is exactly what the Python remote debug run configuration is made for. Let's create one. For the brevity, I'm going to use the same Django application and I'm going to deploy it on the same virtual machine. But this time I'm not going to use the debug button to get access to my running app. Before we start, I need to obtain my host machine IP address because I will need it because my virtual machine will need this IP address in order to get access to it. So let's try to figure out what's IP address. I think This one looks like the right one. All right. So let's now go to edit configurations, Python remote debug, localhost name, this one. Port can be pretty much anything. Name, webinar. All right. So far, so good, but you can see that PyCharm advises us that we should do a few extra actions in order to make things work. The first one is to add the PyCharm debugger to the host machine, to the remote machine. Let's do this. I'm just copy and paste. Okay, everything is good. And the second important part, we should copy and paste this chunk of code right before the place we need to stop. So I'm gonna remove this breakpoint here. I'm gonna paste this code here. Now I'm gonna change my remote interpreter to the one on virtual machine. And let's make sure this time that everything is in sync with the virtual machine. So we are. And now let's try run this remote debug run configuration first. And then, this is an interesting part. I'm going to run my application, but this time I'm going to run it without debug mode. I'm just going to run it on the virtual machine. Here we are. So I will need this IP address again. Let's get access to the web application. Polls. Here we are. I'm doing the webinar. And let's now try to vote. What is happening? Okay, so PyCharm asks us for something. So what does this window mean? PyCharm asks us about mapping between the remote code and your project code. Luckily, auto-detect option works in the majority of cases. So let's give it a try. And the top one looks fine to me. Okay, let's do it. And you can see that we've just stopped on a breakpoint. Not exactly on the breakpoint, but right after the code we've just injected. And from this place, all the debugging functionality is available. So we can step through the code, we can resume. Let's resume and see. So yeah, we are on the results page. Summing up. Use remote interpreters when you have access to the remote server and is able to run the app in the debug mode. Use the debug remote, use the Python remote debug configuration when you are out of control of how the app is running. All right, so this concludes the remote debugging part. Paul, do we have any questions?
We have 100 people who said, Paul, stop whispering, stop typing, you're too loud. So unfortunately, our cable's really short and it's right beside my keyboard. So I will try to do a better job about not typing too loudly. So we have 3 good questions I'll ask you.
Okay.
Can you connect to a Docker image running on a remote host?
Can I connect to a Docker image running on the remote host? Let me think of it. Actually, I think you can by doing some magic with your network settings.
Yeah.
Something like.
But it's something we know about.
Yeah.
Okay, it's something that we've talked about. Can you? This should be a straightforward one. Can I debug unit tests in a Django project running inside Docker?
Yes, why not?
Why not? All right, good.
So the tests breakpoints are just regular ones.
Which will be related to this next one.
Yeah.
Was the debugger running locally or in, don't answer, or in the VM directly? Audience, do you know the answer?
Yes, I do.
Audience, give you a chance. We'll have a little bet on this. And now Andrey will give the answer. What's the answer?
So the answer is the debugger is run on VM. It's not
Ding,
running
ding, ding.
locally.
Where the Python interpreter is running.
Yes, where the Python interpreter is running. So the thing is, the debugger's code is copied to the virtual machine when you run debug. And pretty much the same happens with Docker, but in the Docker case, we just mount the debugger's code to the Docker image. That's it.
For those of you interested in how this magic works, go back and find Liza's talk at PyCon from maybe 3 years ago about how to write your own debugger, because that's what we all want to do every day when we wake up, right? Write our own debugger.
Absolutely.
Exactly.
Okay, so let's move on to your next part, which is about architectural stuff, right?
Oh, yeah. Thank you for your questions. Now let's briefly discuss how the debugger works. It won't be possible to cover the whole topic, but it would be nice to give you some ideas on where to start if you want to learn more about debuggers. So I have a few slides right here. So let me go full screen. All right, so though debugging may look like magic, it actually comes as a platform API. And this API allows you to add hooks to events like a function call, like moving to the next line of your code, raising an exception, and so on. By platform here, we understand some environment that runs your code. For example, operating system that's running CPU instructions, JVM running bytecode, Python VM running Python bytecode, and so on. The example debugging facilities from different platforms are on the slide. You can go Google them if you are interested. Now let's move to the Python tracing API. So Python provides us with this syssetTrace function that is used for setting a tracing callback. Being said, this callback is called every time the program enters a new context. The context here usually means a function. On the slide, you can see an example of a tracing function that does nothing. Note that the callback function, and this is the important information in this slide, must follow some conventions. It must take exactly 3 arguments. These arguments are frame, an object that contains all the information about the current context, the information like function name, position in the source code, local variables, and so on. Event, which is just a string designating the event that just happened for function call, is just call. And args, which are the arguments that function that you pass to your function. So that's pretty much it. So now having this information, we already can implement somewhat usable debugger. The debugger code is on the slide. This debugger accepts a Python file path, runs it, and while running, prints the information about every function about every function that's being called to the stdout. So the code demonstrates the general approach that every debugger uses. So the first thing is activating the debugging API, and this is what you see in the red box here. We're setting the callback using syssetTrace function, and the second part is run the debugging code from inside the debugger using some kind of exec function, the green box on the slide. All right, so now we know how to trace function calls, but in order to be able to know we have reached a breakpoint, we must have the ability to trace a program line by line. How to do this? This can be easily done with the Python debugging API. The tracing function can return another function, and by the convention, this function will be used as a line tracer. The platform will call this line tracing function every time the execution moves to the next line, or function returns, or exception is raised. Paul, do we have time for a short demo?
We have about 2 minutes.
So only questions.
We will do the demo and not the more questions.
Okay.
If you want to give the demo.
Okay, so let's move forward to the demo. So I'm going to switch to another project. So let's call this one. And okay, so let's just let me show you the techniques that I've just shown you on the slides. So the first one is tracing function calls. Here you can see this tracer. Here we set the trace function and a few function calls just to make sure that everything works. So let's run this and look at the output. All right, here we can see that the tracer function has been called each time we entered a new context and in the right order. So first we call the H function, next G, and next F, and then G. So sounds good. So now let's see what will happen if we return the tracing function from the tracing function itself. So here, what we expect is we expect to see that our tracing function now can catch every step that our program makes. So let's run it and a bit more output. So here you can see that the function H is called, and we can see that line numbers are increasing here. So we can see that our tracer can catch the line changing event. And the last one is the debugger that prints every function call and accepts the script as a parameter. I have prepared a run configuration for it, so you can see that we pass example.py as an argument to this program. Let's run it and see what is happening. All right, so we can see that, by the way, you can see here that Python runs some internal stuff first, and we catch these events too. And then you can see that this tracer can trace every function call. And I think that concludes my short intro. The links that will be useful for those who want to know more details will be available.
Yeah, we'll publish it with the blog post and the tweet.
Yeah, thank you.
This is fun. I got to admit, watching this is really fun because you think of the debugger as freaking magic, right? And seeing that these events are generated and an actual human could kind of get into a little bit of that tracing process.
Yeah, so this isn't magic in the end of the day.
Live long and debug. Everyone, go out, make a new debugger, do something fun. All right. Let's switch back over and go ahead and wrap up on this. I apologize. We won't take more questions because we have a lot of great questions, frankly. I think we're going to spend a while following up on all of these questions. So let's go ahead and wrap up.
Yep.
So thanks, Liza. Thanks, Andrey.
Thank you.
Yeah, this was a lot of fun. Taking the time to talk with us about PyCharm debugging. If any of you have any questions later, some of you set the world record for number of questions, and some of them were really good. Blaze, you had some good questions. Thomas had some good questions. Others had some really good questions. But we will follow up on all of this. If you have any more questions later, don't hesitate to reach out to us by email, social media, on Twitter. It will come to me. I will not have the answer, and I will send it to them. Easy. If you'd like to get more information on PyCharm, please go to our website at jetbrains.com/PyCharm. We'd love your feedback on this webinar, so feel free to contact us on Twitter or the after webinar survey. We read it. Fill it out. Tell us what we should do better next time, other topics you'd like to hear, and any questions that you thought of afterwards. Yes, the recording will be available on our YouTube channel soon. Soon meaning eventually, because I might be jet lagged for a few weeks. If you haven't already, please check out our PyCharm blog. On the blog, you'll find up-to-date information, PyCharm news about releases and events. In addition to educational resources, those of you that are still with us, get a sneaky peeky. Anthony Shaw will be talking to us about security assertions in February, so look for that announcement. For example, the recording of this webinar, we'll put it on the blog, we'll tweet it, and we'll also post additional links, right?
Yeah.
The things that we put in the chat window that not all of you could see, the links to the repository and all that. So thanks from all of us for today. Thank you very much for joining us, and hope you have a nice rest of the day.